Number 2 from standard FIF B4, number 2 from the review, they ask you to find a slant asymptote. To find a slant asymptote, you are going to do polynomial long division. You learned this in October, the first unit I came back for. So write the numerator always on the inside, the denominator on the outside. Now we need to make sure everything's accounted for. What I mean by that is the highest exponent on the inside is a 2. So there's x to the first, x to the second, x to the first, and no x's. Likewise, x to the first is the highest, so x to the first and no x's. Everything's counted for. Now I'm going to make little dots just to provide you with some columns to help you out as we refresh this. X times what gives you x squared? The answer is x. And I put it in the column with like terms. So x times x is x squared. X times positive 3 is positive 3x. Go to the second line and change the symbols of everything on the second line. And now combine like terms. The fronts cancel. These two give you negative 2x. We're going to do the process again. X times what gives you negative 2x? The answer is negative 2. Multiply. Change the signs. And combine. With the slant asymptote, we are only going to be concerned with what's on top. So y equals x subtract 2. This is going to be our slant asymptote that we're going to graph. When we graph this, it's a linear line, and there's no number that we can see in front. So in front is really 1 over 1. Come down below and find negative 2. That's your starting point or your y-intercept. And so we have negative 2 here, and you're going to go up 1 and over 1 to represent your slope. So up 1 over 1, up 1 over 1. Then take your highlighter, go through your dotted points. Asymptotes will always be represented with a dotted line, not a solid line. Your vertical asymptote will always come from the denominator, just like we did in problem number 1. So take the denominator and set it equal to 0 and solve. So the vertical asymptote is x equals negative 3. Take a highlighter, go to where x equals negative 3, and make a vertical dotted line through the point x equals negative 3. Grab your calculator, do second plus 712 next. Go to y equals, and we're going to plug in this function using parentheses. X squared plus x subtract 2 divided by x plus 3. Hit graph. This particular view gives me a great idea of what it looks like on top. I can barely see this bottom part. It'd be nice if I could extend the graph downward. So hit window, and instead of having a y minimum of negative 10, let's change it to like negative 15 or negative 20. Make sure you're practicing this so you know how to do it on a test. Alright, so we're going to use the points from the table to allow us to graph this. So please do second table. And so often students say, well, how do I know where to start? Well, let's start with what they give you. Let's start with 0. So I'm going to graph several points from each one of the two sections where the graph occurs. So I'm going to start with 0 and negative 0.6 approximately. 0 and negative 0.6. And 1, 0. And 2 and 0.8. And it looks like it's getting closer and closer and closer to the pink line. Now I want to go to the left. So I want to go to the numbers like x equals -1 or -2. Currently, it doesn't show -1 or -2, but if you use the arrow here and you go upward, you'll be able to see those points. So -1 corresponds with -1, and -2 goes to 0. And you can see how it comes down and then gets closer and closer to both the slant asymptote and the vertical asymptote. It's necessary to do this to get points and not just go, oh, it looks about like this. I can see from the original graph that the next portion of this function occurs down below in this part. So to go back to second and table, I'm going to pull x values that occur down here. So x's would be -4, -5, -6. I'm going to graph these ordered pairs. -4 goes with 10. -5 goes with -9. -6. And -7. Again, make sure that both the top part of this fractional function and the bottom have arrows that go in both directions. Okay, end behavior. So f of x, as x goes to -infinity, as x goes to +infinity. Remember, -infinity is the left, +infinity is the right. So as this function goes off to the far left, as it continues to go off to the far left, which direction is this graph going in? As we go to the left, it's going down. You're going to use things like up, down, or it's going to be going towards a y value, or like a flat plane. So as we continue to go to the left, you see how this thing continues to go down and down and down and down? So as we go to the left, it goes down, -infinity. And as you go to the far right, if you go to +infinity, it continues to go up, +infinity.